All right, welcome to the System Terminal, everyone. I'm your lead dev for today's explainer, and we are running a full-on Cambridge exam hackathon. Our target mainframe, the Afrikaans AS-level food and drink topic, specifically focusing on healthy eating and fast food traditions. Today, we're going to treat your essay responses exactly like an algorithm. We will break down the precise theoretical architecture the examiners are testing and equip you with the code-like syntax you need to clear the firewall and secure maximum marks. Let's boot this up.
Take a look at this quote pulled straight from the Principal Examiner reports. This topic appears in every examination series. Okay? This is a core kernel of the syllabus. You literally cannot skip it. Mastering this isn't just about hard-coding some vocabulary into your memory. It's about understanding exactly how the examiner expects you to process and output data. It is absolutely non-negotiable if you want a high-scoring system.
So here is our command matrix for today. First, core principles and theory. Second, technical exam methodology. Third, advanced critical analysis. And finally, top examiner warnings.
Initiating Section 1, Core Principles and Theory.
To successfully hack this exam, we really need to look at the underlying system architecture. It's not just about writing a basic essay on why an apple beats a burger, right? The examiners are testing 3 specific cognitive domains. At the base level, you've got knowledge and understanding. Think of this as your raw data inputs. We see students, let's call one Dev Alex, who are great at inputting raw facts but fail because they stop there. To get the top grades, you got to run the logic loops. Analysis, where you parse and break down the data, and evaluation, where you compile justified judgments. If your code only runs in that first knowledge domain, you're going to cause a massive memory leak of lost marks.
Now here's an insider patch straight from the examiner reports. Cross-topic connections achieve significantly higher marks. Don't let your data sit in an isolated silo. Can you link the rise of fast food traditions to other network nodes in the syllabus, like societal shifts, economics, maybe cultural changes? The examiners highly reward coders, students that is, who can zoom out and map these broader network pathways.
And to make those connections work, you need to lock down this variable, causal relationships. This means providing the precise links explaining exactly how specific food choices lead to direct outcomes. You can't just output, fast food is a modern tradition. No way. You have to write the code that shows how the shift toward convenience created that tradition and what the direct health or social outcome actually is. Nailing these causal relationships is the absolute backbone of a high-scoring string of text.
Moving on to Section 2, Technical Exam Methodology.
Did you know you get marks literally just for the way you process a problem? These are your method marks. Think of this as your core algorithmic sequence. Step 1. Identify the key elements in the prompt. Step 2. Apply the relevant principles you've stored in your database. Step 3. Execute your analysis. And here's the kicker, show you're working. Let the examiner see your logic loops. Step 4. Verify the results. Step 5. Present it all in the correct format. If you treat your answers like a rigorous piece of software engineering rather than just creative writing, you'll naturally extract those vital process marks.
Speaking of that final presentation step, man, examiners are like strict compilers. They demand strict conventions, proper headings, correct Afrikaans terminology, appropriate formats, and clear annotation. This is your syntax, people. If you drop proper headings, you trigger an immediate syntax error, and the examiner flags you as a weak candidate. Before we push any final patches today to secure those maximum marks, take a quick second to optimize your own system feed. Subscribe to Ace the Exams right now and turn on all notifications for weekly system updates. Seriously, don't miss out. Okay, back to the code.
Booting up Section 3, Advanced Critical Analysis.
This is the highest order domain. This is what separates an average student from a top-tier developer. We see this all the time. A student, let's call them Dev Sam, writes a purely descriptive answer. They just list what a fast food tradition is. But an evaluative answer? That requires comparative logic. You've got to actively highlight similarities and differences. Think of it like deploying the Peel syntax structure: point, evidence, evaluation, link. You have to use comparative connectives to bridge your thoughts, and every single comparison must be backed by evidence to clear the examiner firewall.
So, how do we debug and evaluate that evidence? Run it through this exact checklist. Whenever you're dealing with data on healthy eating, you must identify the limitations, note any hidden assumptions, look for alternative interpretations, and finally, assess what effect those bugs or limitations have on the final conclusion. If you justify every single recommendation using this framework, your analytical score will absolutely skyrocket.
Entering Section 4, Top Examiner Warnings.
Let's look at the system logs. These are the direct, unvarnished, fatal errors pulled straight from the principal examiner reports. Number 1, forgetting proper format. Like we just said, bad syntax is the fastest way to crash your grade. Number 2, failing to check your presentation before hitting submit. And number 3, this is the biggest logic error of all, providing answers that are not specific to the context given.
Examiner alert. You have to stop providing generic answers. You might have precompiled a beautifully coded paragraph about the nutritional deficit of fast food, but if the prompt is asking about the economic impact in a specific scenario, and you just paste in your generic nutrition answer, 0 marks, total system failure. You must always link every single point you make directly back to the target scenario.
Okay, so how do you encode all these strict syntax rules and evaluation checklists into your brain's hard drive under intense exam pressure? Time for a memory hack. Deploy the visual story method. Instead of just memorizing text, create a vivid mental image that links the methodology together. Imagine yourself as a lead dev, first identifying the bug, running the logic loop, testing the code, and deploying the final patch. Encoding it visually makes it incredibly fast to retrieve when the exam clock is ticking down.
We've mapped the system architecture, the algorithmic frameworks, and the strict syntax warnings from the examiners themselves. I'm leaving you with this final prompt for your next beta testing arena. Look at your recent past papers. Are your practice answers just generic code blocks, or are they perfectly linked and optimized for the exact exam scenario? Take this cheat sheet architecture, apply it to your next practice run, and watch your grades compile flawlessly. If this hackathon helped you out, subscribe to Ace the Exams right now, hit that bell, and leave a comment below with your subject and level so we can target our next update. Keep optimizing, and I'll see you in the next explainer.